Excellent. Now, I just want to review these two equations, and I'm going to do a couple of labs, quick demonstrations on what we're talking about by the production of either a precipitate or something molecular, like a gas or water, to drive a reaction. This is serious chemistry. Okay? Now, the first reaction is I take lead nitrate and I combine it with sodium iodide, both of which are aqueous. And I have them right here. Okay? This is sodium nitrate. It's liquid. This is a cloudy solution, and this is lead nitrate. But it's still an aqueous solution. An aqueous solution is a water solution of a salt and water. Okay. Now, so I'm going to take that, I'm going to form lead iodide, which is a precipitate, and you got to look very carefully at the reaction because the reaction is very subtle, and so you want to make sure that you see the reaction clearly, okay? And then this is aqueous here, so this actually doesn't take part in the chemical reaction. Clear? Okay. The next one is going to be sodium carbonate, which is here, and I have it in a particular flask. This is called an Erlenmeyer, E-R-L, Erlenmeyer, E-N-M-E-Y-E-R, Erlenmeyer flask. And I have it in here because you'll find out. Okay. And I'm going to mix that with acid. You all have had this acid before. Okay? You have. It's called acetic acid here. So I'm going to take the sodium carbonate, I'm going to mix it with acetic acid, vinegar, okay? And then I'm going to produce sodium acetate, and then carbonic acid, which we know, remember, it's a weak acid, and it automatically goes into carbon dioxide, a gas, and water, a liquid, but these are moleculars, right? They're molecules. They have covalent bonding, okay? So let's do this. All right, I want to do this. Okay, can I see the reaction here on the table? Let's do this. Let's take this off here and take that down. Take those off, all of them. Okay. And then we'll put this here. And you can clearly see the desktop. And we'll tilt it a little bit. Thank you very much. Miriam and Isis are my videographers. All right, so this is the first experiment. This is the first experiment. So I'm going to take these and I'm going to, I'll just mix them. Are you ready? Mm-hmm. Yes?
Yes.
Sodium iodide, and lead 2 nitrate. Cool, huh? So, what color do you think is the, just guess, wild guess, what color is the lead iodide?
Yellow.
Yeah, yellow, yeah, it is. And I'm going to let that down, and you're going to see the beginnings of that settling. Yes, it's a fine powder, but it formed. It's a fine powder. You guys at home can see it? Okay, I'm taping this, not through this. I'm taping this through a iPhone. The other thing is just worthless. All right, so that, and you'll see, I'll show you that again in a minute, and you'll see things are settling, okay? Now the next one is actually kind of fun, okay? This is exactly what it appears to be, and we're going to talk about it in a minute, but this is a candle. Nothing weird, it's just a candle. Okay, can you see that?
Yes.
Okay. Now, I'm going to take some acid, okay, and I'm going to put it in here, okay? You ready?
Yes.
So this is acetic acid. It's actually a very dilute solution. Glacial acetic acid is very concentrated, but this is more mild. Vinegar, yes? Clear? And voila. Okay?
Like in the
So I
movie.
get a lot of bubbles, right?
Like
A lot of
in
bubbles,
movies.
right? Yes? And so
We often see
so
it in the movies.
so what we're gonna look at is we'll look at what we'll do is I'll put some more in there just to make sure I have a lot of bubbles. And we're gonna check to see what kind of density, can you see this? What kind of density, right, so this is carbon dioxide, it's in here, or maybe it left. Let's see if it's still there. Let's see if it's heavier than air. You ready?
Oh my gosh.
Oh,
I just poured it out. Kind of cool? Cool or what?
Yeah.
I'll dump some of that liquid out. Okay, and I'll make a little bit more. Let me light this. I need a splint, but
yeah, it smells like.
Don't burn your
okay. So I have plenty of sodium carbonate left. So I'll make a little bit more, right? And I'm going to pour it. I'm going to pour it in. You ready? Just pour it. Isn't that cool? Or I can take a little piece of paper. Okay. Make some more here. Okay. So in other words, what do you think? What's your guess? You think carbon dioxide is more dense than air, or more or less dense than air? More. Yeah. The atomic weight of carbon dioxide is 44. Yes.
Yes.
Now air is mostly nitrogen, N2, right? That's 28. All right, there's some oxygen in there, which is 16, 16 is 32. The average weight of air is about 29. 29.5, 30 at the most. So carbon dioxide is not only more dense than air, it's about 50% more dense than air. Yeah. People don't realize. So that's not escaping. That's just sitting in there. Now, if it were less dense than air, it would leave. Correct? Right? Mary was just fired.
I know it just fired, but it's paper too.
It's not gonna do anything.
Paper can be like really.
That little amount of paper.
Okay, so here's the paper. Ready? Ready, Bernie?
Oh.
So there's carbon dioxide that's trapped in there, isn't there?
It's still fire.
The smoke is floating in the glass.
Right? Are you okay?
Okay, now it's
Yeah. Okay. You ready?
this is like paper.
Sir, don't burn yourself.
The smoke
You just don't curse.
Wow.
Magic.
Finish. So, what we did was, get those books. Where are those books? The books.
And can we drink the yellow thing?
It's lead.
It's not drinkable.
Yeah, you don't want to drink lead. You don't want to drink anything with lead in it.
Lead is
You know, there was a no, don't do that, because I want the lead to settle. Okay? The lead iodide, I want it to settle. Okay? So what we did was, let's just review. So we took an aqueous solution, of lead to nitrate. We combined it with an aqueous solution of sodium iodide, and we produced, Elvis? Thank you. And we produced lead 2 iodide and sodium nitrate. Clear? Okay? And now, let's see if there's any signs of it settling. And you can definitely see the precipitate at the bottom
Yes.
forming. Do you see that? You see that? Is that clear on your side of the camera? Yes?
What happens if you pour it out? Does it come liquid or does it stay?
No, it would kind of like be a slush. Yeah, it would mainly stay there, but then you'd have a slurry. But what I'm going to do is I'm going to put this away, and then on Monday we'll look at it again. I'll lock it up, and we'll look at it again, and you'll see that the liquid is clear on top, which is a solution of sodium nitrate and water. And then on the bottom of the beaker will be the lead 2 iodide. Clear?
Yes.
Easy? Good? Okay. And then this was a candle that was extinguished with carbon dioxide. Now, one of the early types of fire extinguisher was using carbon dioxide. It was a chemical reaction inside, you turned it upside down, and it was a chemical reaction of an acid and a salt that produced carbon dioxide, a molecule, yes, and that carbon dioxide was forced out of the extinguisher, and that's how you fought fires. They're carbon dioxide extinguishers. Clear? Yes?
Why did they stop using it?
Because they came up with better ways of doing it. You know, anti-fire foams and things of that nature, powders. The idea is to smother the fire. You can smother the fire by using carbon dioxide, by using sand, a wet towel, a fire blanket. Give me that fire blanket in the back, please. It's hanging on the towel rack. You see it? I just leave it out like that because it's easier to get. Okay? Yes?
Wouldn't a chemical reaction releasing a lot of carbon dioxide be, wouldn't the container be under a lot of pressure?
I'm not sure I heard your question, but if you're producing carbon dioxide, and carbon dioxide is a gas, and it's contained, it will produce a pressure. Like you could see the water, the carbon dioxide came right out of the beaker. It was like foam, wasn't it? That could be a fire extinguisher producing a foam, and the gas that's making the foam is carbon dioxide. It's certainly reasonable to assume that. Now this blanket is made of material that doesn't catch fire. Okay? Doesn't catch fire. Now, you'd really have to work hard at even making the smolder. So you take this and you simply smother the flame. That's all you're doing. It's called a fire blanket.
Can you show us?
No, I'm not going to make a fire and show you. It's not going to happen. All right, end of video.